All right, so read the first one. What are we given? So always read that first. Position. And they usually give you position or velocity. Rarely do they give you acceleration, but make sure you're paying attention to what you're given. So it says find the velocity vector, the acceleration vector, and expression for speed. So velocity and acceleration are just going to be your first and second derivative. So what is our derivative for this first part? Let's see. Derivative of sine would be cosine. You would have to chain on a 1/2, which is actually kind of nice because what will happen? Yeah, it's going to cancel. And you can write t over 2. I actually prefer 1/2 t. That's my personal preference because it makes me realize there's a coefficient of a half. You can write t over 2. That just comes down to what you prefer. And then this one's going to be like the same thing, except derivative of cosine, negative sine, 1/2 t. So that's all there is for that. Acceleration. Now we're going to do derivatives of those. So for the first one, it will be negative, good, 1/2 sine 1/2 t. And then this will be negative 1/2 cosine 1/2 t. Derivative of sine is cosine. It just already was negative, so you just keep the negative. All right, and then speed is that big old square root thing, just without the integral in front of it. Total distance, you just slap an integral in front of it. Average speed is the 1 over b minus a and then integral a to b. And it says average speed, you're doing an average value for the speed. And then you're going to have all these things squared in here. So you can set it up blank. And now we have position, velocity, and acceleration. We have all three of them now. Which one is the one that goes in there? Velocity. So basically just copy these ones over. So cosine 1/2 t, and then this would be negative sine 1/2 t. When you square something that's negative, though, it's going to turn positive. So this actually does simplify a little bit further. I think we talked about this identity last time or the time before. I can't remember. I think it was last time. Sine squared, because this will turn positive, sine squared plus cosine squared.
Oh, it's 1.
1. And your square root of 1 is 1. So that tells us our speed is what? Which is our speed is constant. It's like you're on cruise control, right? So speed is constant. So for part B, when it says, is the particle speeding up or slowing down? Neither. Because speed is constant. I'm still going to go through the explanation of how you would justify that if speed wasn't constant, like how you would check that, just so that, you have to look at both velocity and acceleration at whatever time they said. So this says at time 0. So we're going to do velocity at 0 and acceleration at 0. And basically all the BC topics that we're doing here, it's still the same as it was in AB. It's just now you have a parametric equation. So it's really the only difference. So velocity at 0, we're going to plug in 0 right here. Cosine of 0, 1. And then comma, sine of 0 is 0. And then same thing for acceleration. If you plug in 0, sine of 0 would just be 0. So times negative 1/2, that would just be 0. Here though, cosine of 0 is 1 times negative 1/2 would be negative 1/2. So here's what that would look like, because I think the visual helps. Like, I'm a very visual person. I like to see it. Wherever point you are on that graph, and I didn't make you graph it, you're welcome. Okay. But your velocity, and here I'll use colors so that when I post this, the colors will be on there. Wherever you're starting, velocity is telling you to go 1 in the X direction, nothing in the Y direction. So it would look like that. Come in with me. Like you're being pulled, or you're going that direction. Acceleration is what's pulling you, though. It says go nothing in the X direction, negative 1/2 in the Y direction. So do you see how they meet at right angles like that? So you could also say neither, because velocity and acceleration vectors meet at a right angle. That would be another acceptable like justification for that. But we had already found speed was constant, so I just wrote that. Cool so far? All right. Velocity is what we're given here. Our velocity. Oh, and what do you notice about it? Constant. When time is nothing, the particle is at the point 2, 1. So this is our initial condition. Because this is constant, you can actually get the answer without doing any work. I'm still going to then work it out, but when it's constant, watch what you can do. If you start at 2, and what time was that? It was time 0, wasn't it? Time 0. We want to go 2 seconds later. So if this is your velocity, 2, and you go that for 2 seconds, 4. So 2 plus 4 is 6. Do you see how you can do that when it's constant? Now that was a bunch of 2's, so sometimes that gets like lost on everybody. Let's do it for the y's. We start at 1, velocity is 4, and we're going to do that for 2 seconds. So if you go at a velocity of 4 for 2 seconds, 8 plus 1 is 9. So you can actually get that without doing any work because those are constant. But hey, what if they weren't constant? Like part B in the warm-up that we just did. Okay, so I'm going to actually work it out just so you, like, humor me. If it wasn't constant, you would have to work it out. So for x, starts at 2 plus, and then what do you set up? Integral where to where, or when to when, I guess I should say. 0 to 2, and then what goes inside of there? 2 dt. And then you would work that out. So it would be 2 plus, what's your antiderivative of just 2? 2t, such that 0 to 2. And it would be upper boundary minus lower boundary. So 4 minus 0, you end up with 6. Humor me, we're going to do y as well. Again, if it wasn't constant, this is how you would have to do the problem. So it starts at 1 plus what? Four dt. So that would be 1 plus, and then your antiderivative of 4 would be 4t, 0 to 2. Upper boundary minus lower boundary would be 8 minus nothing. 1 plus 8 is 9. See, you're all survived. All right, B says total distance. That was like part D on the one that we just did, the warm-up we just did, except we're going to actually work it out this time. All right, so it would be integral 0 to 2, and then what am I going to draw? For total distance, a huge square root. What goes underneath there? Actually, I guess it won't need to be that big this time because they were like the velocity was constant. I guess it won't need to actually be that large. I'll have to erase some of it. But what's going to go under there? Look back here. Yeah, 2 squared plus 4 squared dt. So what's that going to give us underneath of there? Is that 20? This would be 4. That would be 16. So square root of 20. So what's your antiderivative of square root of 20? It's kind of like when you do an antiderivative of 2, it's 2t. So antiderivative of square root of 20 would be like square root of 20t. Like square root of 20 is just a number. It's just a little bit of a weird looking number. Such that 0 to 2. And so your final answer would be 2 square root of 20. To get from velocity to position, you would have to do an antiderivative, but I already made you do them, so I'm not going to make you do them again. We can actually just write this answer. And I don't know why they use R for this, but anyway, R of t is for your position. Look back at part A. What did we get for our antiderivative for the x part? Do you see this right here?
No,
2 plus 2t. I'm not going to make you do it again. We already did it. And then what would it be for the y part? Look back at part A. 1 plus 4t. We just didn't plug in any actual numbers. We just wanted the like in general formula, so we left the t's in there. All right, so for number 3, you're given a position vector, so position, not velocity. When is speed a minimum? Okay, first let's write an equation for the speed. That's that big square root thing, just without an integral on the front. All right, so let's go ahead and do that. It'll be something squared plus something squared underneath of it. Just don't do an integral. If you put the integral in front, it makes it your total distance. But actually, these are not what go in there, because this is position. What needs to go in there? Velocity. So we need to take a derivative. So derivative of t, 1. Okay, that's the easy one. Derivative for this part would be what? It would be -6 plus 2t. Can I write 2t minus 6, though? Is that okay with everybody? That just, like, that's a personal preference, but it sits better that way if you just do that. So let's actually work that out. All right, we're gonna have to do, welcome back to algebra class. We're gonna have to do some algebra. 1 squared is just 1. Now 2t minus 6 squared. You have to imagine in your head a 2t minus 6 and another 2t minus 6. Are we imagining that? And then distribute everything together. So what would that give us? Oh, yes, you're right. You're on the second step. Can we do the first one first? Like the 2t part times 2t. Be 4t squared. Why would it be minus 24t? That's right. Where'd you get that?
-6 times the 2t times 2.
There's 2 of them. So it's like -12 and -12. So -24t. And then -6 squared would be 36. And there's really not a whole lot you can do to clean that up except add the 36 and the 1 together. So we found an expression for speed. Like we found a formula for speed. Go back to the question. It's asking, when is speed a minimum? Maximums and minimums happen at what points? This is a vocabulary word we did during Battleship, and no one knew it, so throwing it out there again. What is it? Critical points. How do you get a critical point? Oh, that's you're doing absolute math. Your brain's in the right unit though. Derivative equals 0. We're going to do the derivative of this. I know you can't wait, and set it equal to 0. It's actually not going to be as bad as you think. Does anyone remember how to do a derivative of square root? Pretend it's not all this yucky stuff. Pretend it's just square root. It's on the bottom? Good. It's 1/2 square root. So 1/2 square root of whatever. 1/2 square root. And then you're going to chain on the derivative of what's inside. So that's going to go in the numerator. That part won't be so bad, and that's actually the part we're going to work with. So what's the derivative of just the guts of it? That's what's going to go up top. Derivative of just the insides. Good. And we're setting this equal to 0. Here's the good news. You just need to set the numerator equal to 0. I'm glad we reviewed how to do a derivative of a square root. That's something you need to know. But you really just need to set the numerator equal to 0. So if you do 8t minus 24 equals 0, what is that going to give you? 3. So let me recap, because there was a lot going on there. We found an expression for speed. We had to do some algebra. That wasn't fun, but you all survived. We did a derivative. Again, the square root, it kind of looks nasty, but then you just really set the numerator equal to 0. We get times 3. There was a lot of calculus in that problem. You had to understand how to set up speed. You had to know how to do a derivative of a square root. You had to understand that minimum meant critical point. You had to know that that meant derivative equals 0. I like that question. I pulled together like so many things. All right, one more. Particle is moving, times are positive. X component has a velocity of this. Y component has a velocity of this. So they gave us like basically a velocity vector. They just wrote it separate like that. Part A, and actually we'll just do the first part of part A. It's like part A1. Moving to the right, left and right, would that be X or Y that we're looking at? Which component? The X. And moving to the right means that this would be Positive. Okay, so we're going to take this 2e to the t and say that needs to be bigger than 0. Well, before I say anything, I was going to put a leading question in there, but I'm just going to go with what do you think? It's always above 0, right? Because exponential is the swoop thing. So that's above 0 all the time. So all times. Now we're keeping times positive, so it would just be times bigger than 0. All times. That is positive all the time. I love the exponential equations. They're always positive. Sweet. Unless they got like reflected or something. All right, now the second part of part A, when is the particle moving up? Up and down is y, and moving up means that y should be positive. Again, positive. If it said down, it would be less than 0. So we're going to take this 1 minus 5 over t plus 1, set it bigger than 0. Now that one we're going to have to actually like do some work for. Okay, so what would you do next? Now you could either subtract the 1, or you could add the 5 over t plus 1. Can we actually go with that instead? Because that'll make everything positive. Either way will work. I'm going to just try to keep everything positive if that's okay. Because when you divide by a negative, then you have to like remember to flip the symbol around and it gets messy. All right, then what? All right, multiply over the t plus 1, which would just be t plus 1 greater than 5. And so t greater than 4. Cool. So left and right is x, right is positive, left is negative, up and down is y, same thing. Up is positive, down is negative. All right, here's our initial condition. Position, r is position for whatever reason. X is 1, y is 4. Find the position vector. Gosh, can't talk. So we're going to do the x and the y separately. How would we set up x? It will be an integral, but first, what'll go in front of the integral? Yep, 1 plus integral from when to when? Or I guess it'll just be where it starts, right? What number did we start at? Yeah, 0. And we just want the position vector, so it'll just be to t. Like getting that vector means you just want to leave the variable in there. And then what's going to go inside of there? Yeah, 2e to the t. dt. So that would be 1 plus, and then what's your antiderivative for 2e to the t? Yeah, 2e to the t, such that 0 to t. Technically, we should have changed one of those variables, but I don't. I'm just like, whatever. So it'll be 1 plus, oops. And then upper boundary minus lower boundary. So if you plug in t, you would just get 2e to the t minus, now if you plug in 0, you don't get 0. If you plug in 0, 1 times 2, 2. So it would be 2e to the t minus 1. So that's what we get for x. And at the end, I'm going to put it all together. But like you have to do these separately. Again, it's exactly what you do in Calc AB. It's just now you have 2 of them. You have to do 1 for x and 1 for y. All right, so how is y going to be set up? It's going to be the same thing, but with different numbers and a different equation. Yeah, 4 plus integral 0 to t. And what was that one? This one's a little bit messier, just as a heads up. You got that fraction in there, but I believe in you. All right, so that'll be 4 plus, and I'm going to bracket this off. I should have bracketed this one too, because that 1 is kind of separate from this. Antiderivative of just 1. T, good. Minus, I'm just going to throw the question out there as well. Like, any thoughts on how to do that one? I'm obviously going to tell you if no one remembers, but I'm just like seeing what we got. Let me cover this up. Pretend that's not there. ln, good. And the 5 is sort of just there. It'll be 5 ln t plus 1. I knew if we stared at it long enough, it would come to us. And then such that 0 to t. It's basically just like symbols overload. All right, so it'll be 4 plus upper boundary minus lower boundary. The upper boundary, you're just plugging in t, so like it would just be that. And then minus, I'm pretty sure if we plug in 0, we just get 0. Let's see. Well, t would be 0. 0 plus 1 would be 1. ln of 1, 0. So actually, if you plug in 0, you're just going to end up with 0. So this is what we get. I should have left more room for B because part C is going to be like nothing. So anyway, for part B, putting it all together, our position vector would be r of t equals, and then that like pointy bracket, 2e to the t minus 1, comma, all of that. So again, it's the same thing you did in AB, you just have to do it separately. You have 1 for x and 1 for y. And then the acceleration vector, this doesn't really need any room at all. We're just going to do a derivative and write our answer. So what's your derivative for x? Yeah, 2e to the t, that's the easy one. And then for y, well, derivative of 1 would just go away. So here, watch, this is what we have. I would not, you could do a quotient rule if you, are you thinking quotient rule? You can do that if you want, but you can also write this as negative 5 t plus 1 to what power? Yeah, and then it becomes a little bit easier. If you bring that negative 1 down, it would be 5, and then this would drop to a negative 2. So it would be 5, and then what? If you had all that stuff to the negative 2, it'd be squared and it would be, yeah, good, on the bottom. So t plus 1 squared.